Section 2.2 is about divisibility, and we have some very simple objective here, and that is to determine whether a number is divisible by 2, 3, 4, 5, 6, 8, 9, or 10. And to some extent, you're probably familiar with that idea already. For example, divisibility by 2, you may know that, but a number is divisible by 2. In other words, if it's an even number, if it's ones digit, it's a 0, a 2, a 4, a 6, or an 8. In other words, if it has an even ones digit. Most of you know that, and so we're going to use that in our work. So when we look at some simple exercises here, determine whether each number is divisible by 2. Number 1, the ones position is the ones digit is a 4, that's an even number, so in other words, that number is divisible by 84 is divisible by 2. Here, the ones digit is a 9, which is an odd number, so it's not divisible by 2. And here, the ones digit is an 8, and 8 is divisible by 2, so therefore, the whole number is divisible by 2. Similarly, in number 4, the ones digit is a 5, so it's an odd number, not divisible by 2, so the whole number, 2,225, is not divisible by 2. So as you can see, that's a pretty straightforward thing. Now, you may even know about divisibility by 3. And that is, a number is divisible by 3 if the sum of its digits is divisible by 3. What does that mean? Well, we're going to look at some examples here in just a moment. But so as the first one, we have the number 17,216. The sum of the digit means we add 1 plus 7 plus 2 plus 1 plus 6. So 1 plus 7 plus 2 plus 1 plus 6, which is equal to 17. And since 17 is not divisible by 3, the number 17,216 is not divisible by 3. So when we look at some other examples, we look at number 5, we look at the number 111, is that divisible by 3? Well, the sum of the digits is 1 plus 1 plus 1 is 3, and 3 is divisible by 3. So in other words, that number is divisible by 3. When we look at the number 6, 1,111, we find 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, and the 4 is not divisible by 3, so this number is not divisible by 3. So that's how we do the sum of the digits. If you look at number 7, the number 309, we add the digits. 3 plus 0 is 3, plus 9 is 12, and 12 is divisible by 3. So therefore, the number 309 is divisible by 3. So it's a very simple test. Now, divisibility by 6, a number is divisible by 6 if its ones digit is a 0, 2, 4, 6, or 8, in other words, if it's even, and if the sum of its digits is divisible by 3. So let's determine whether each number is divisible by 6. So we look at number 420. And first of all, is it an even number? Yes. It ends in 0, so by this criterion, it is divisible by 2. We know that, it's an even number. Then we take the sum of the digits. 4 plus 2 is 6, plus 0 is 6, and 6 is divisible by 3, so therefore this number is divisible by 6. Or another way of saying it is that 6 is a factor. Okay, now for the number 106 in exercise 10, it's an even number and ends in a 6, so that works. But when we take the sum of the digits, 1 plus 0 is 1, plus 6 is 7, and 7 is not divisible by 3. So therefore, this number, 106, is not divisible by 6. Now number 11, since it's an odd number, it ends one's digit is a 1. So it's not even divisible by 2. So it's not divisible by 6 because it does not end in a 0, 2, 4, 6, or an 8. So no. We don't even need to consider whether the sum of the digit is divisible by 3. It happens to be, but that only says it's divisible by 3 and not by 2, in addition to that. So then we look at number 12. Well, it ends in a 4, so it means it's divisible by 2. It's an even number. That works. And now for the sum of the digits, 4 plus 4 is 8, plus 4 is 12. And since 12 is divisible by 3, this number, 444, is divisible by 6. Next, we consider divisibility by 9. And it turns out the test for divisibility by 9 is very similar to the test for divisibility by 3. And simply this. A number is divisible by 9 if the sum of its digits is divisible by 9. So, there you have it. And here we're going to have some test cases here, determine whether each number is divisible by 9. So 16, well, 1 plus 6 is 7, and 7 is not divisible by 9, so that number is not divisible by 9. Here we have the sum of the digits. 1 plus 1 is 2, plus 7 is 9, and 9 is divisible by 9, so this number 117 is divisible by 9 because the sum of its digits is divisible by 9. Number 15, the number is 930. When you take the sum of the digits, 9 plus 3 is 12, plus 0 is 12, and we know 12 is not divisible by 9, so 930 is not divisible by 9. And for number 16, when we add the sum, we take the sum of the digits, 2 plus 9 is 11, plus 2 is 13, plus 2 is 15, plus 3 is 18. So the sum of the digits is equal to 18. Let me just write it out since it's a little bit longer number. So the sum of the digits is 2 plus 9 plus 2 plus 2 plus 3. So we add each of the digits, and that's equal to 18. And since 18 is divisible by 9, 29,223 is divisible by 9. So the answer is yes. So it's a very simple test. Divisibility by 10 is also very straightforward. In fact, you may already know about it. But a number is divisible by 10 if its ones digit is 0. So it's a very simple test. You just look at it and look at the ones digit. Is it a 0? Then the number is divisible by 10. So number 17, the ones digit is a 5, and therefore this number is not divisible by 10. In number 18, exercise 18, 847, the ones digit is a 7, and so that means the number is not divisible by 10, because unless it's a 0, it's not divisible by 10. Now we look at exercise 19. The number is 300. The ones digit is a 0, so that tells us the number is divisible by 10. Similarly, number 20, the ones digit is a 0, and so that tells us that the number itself is divisible by 10. And divisibility by 5 is also very simple. And that's if a number is divisible by 5, if its ones digit is either a 0 or a 5. So we just look at the number, look at the ones digit, is it a 0, is it a 5? And if so, then the number itself is divisible by 5. So here we have some exercises to determine whether each number is divisible by 5. For number 21, the number is 5,780. The ones digit is a 0. Therefore, the number 5,780 is divisible by 5. The next exercise, the ones digit is a 7. And that tells us the number 3,427 is not divisible by 5. In number exercise 23, the ones digit is an 8, and so for the number to be divisible by by 5, it has to end in 0 or 5, and it does not. It ends in an 8. So this number 34,678 is not divisible by 5. Exercise 24, the number ends in a 5, so therefore the number itself, 7,775, is divisible by 5. Okay, so it's, again, there's nothing complicated about this. It's very straightforward. The only thing is you have to remember these details. You know, for this example, if a number is divisible by 5, look at the ones digit and see if that's a 0 or a 5. Next, we're going to look at divisibility by 4. And it's very similar to the test for divisibility by 2. And so a number is divisible by 4 if the number named by its last 2 digits is divisible by 4. So we look at the last 2 digits and see if that's divisible by 4. And that's generally a pretty simple thing to do. For instance, when we look at number exercise 28, the number is 23,524, and the number named by the last 2 digits is 24. And since 24 is divisible by 4, the number 23,524 is divisible by 4. So then we look at some other exercises. For example, exercise 25. The number is 216. The last 2 digits are 16. And we know 16 is divisible by 4. So that means 216 is divisible by 4. So that's a yes. In number 26, exercise 26, the number is 217. The last 2 digits are 17. And we know that 17 is not divisible by 4, therefore 217 is not divisible by 4. And in number 27, the number is 5,862, and since 62 is not divisible by 4, the number 5,862 is not divisible by 4. So again, a number is divisible by 8 if the number named by its last 3 digits is divisible by 8. So let's look at some simple exercises to test this. So here we are asked to determine whether each number is divisible by 8. So we look at number 29, and we take the last 3 digits, 564, and divide that by 8. And since that's equal to 70.5, in other words, this number 564 is not divisible by 8, the whole number 7,564 is not divisible by 8. For number 30, the last 3 digits are 864, so that was number 29. And now for number 30, we'd have 864, the last three digits, divided by 8, and that's equal to 108. So since the last three digits of this number are divisible by 8, the whole number is divisible by 8. Yes. And for number 31, the last three digits are 560. And 560 divided by 8 is equal to 70. So in other words, the last three digits are divisible by 8. So therefore 17,560 is divisible by 8. When we look at number 32, the last three digits are 716. And when we divide 716 by 8, we get 89.5. In other words, 7 and 16 is not divisible by 8. Therefore, 25,716 is not divisible by 8. And last but not least, there's divisibility by 7. And there's a test for that, but it's really quite involved and quite complicated to administer. And so it's usually better just to either use a calculator or do long division to determine whether a number is divisible by 7. A similar comment applies to divisibility by 11. That can also be done, but it's quite involved, and in most cases, it's easier with the availability of calculators to determine whether a number is divisible by 11. Simply put in your calculator, see if there's a remainder. If there's no remainder, then it's divisible by 11. So anyway, this concludes section 2.2.